Hello, in this video we're going to look into how to find the ideal sample size. We use this formula, n is equals to p hat times q hat times z start, which is the z-score, divided by margin of error times square. So where does that come from? You think about the margins of error equals to the z star times the standard error, which is p hat q hat divided by n. Now, because we want to find the ideal sample size, that means we want to solve for n. Okay, so in order to solve for n, we need to divide it by z scored on both sides. So now I have a square root of p hat q hat divided by n. Then I square root on both sides. I have ME margin of error square equals to p hat q hat over by n. So now here is some algebra trick. If 4 over 2 equals to 1/2, right? If we flip it on both sides, the equation still stands. Still valid. Oh, sorry, 4 over 2 should be 2/2. So when I flip it, I have 2 over 4 equals to 1/2. See, the equation still stands. So that means in order to solve for n, I can flip this upside down. I have z-score divided by margin of error and then square them equals to n over p hat q hat. Now, p and q is in the denominator. To solve a denominator, we can multiply p hat and q hat on both sides. So our n is equals to z start margin of error square times p hat q hat. So that's where the formula come from. Okay, now it is believed that 25% of the adults over 50 years old never graduate in high school. We wish to see if the same is true among 25 to 13 years old. How many of this younger age group must we survey in order to estimate the proportion of non-graduates to win 6% with 19% confidence of interval? So our formula, n p hat q hat z start margin of error square. What do we need? We need p hat and q hat. But basically, if we know p hat, we will know q hat. So that means I need to know where is p hat, where is the z-score, and the margin of error. Then we will be able to calculate the ideal sample size. Now let's take a look at what we see lots of numbers here. Which one are useful? We have 25%, 6%, 90%, 50, 25, and 30. First of all, we need to be able to identify the useful information, which one are the misleading information. 25% of the adult, so that gives you the proportion p hat. 50, well, this 50 means 50 years old. It has nothing to do with the statistic, so we can cross them. 25 and 13, also the age, it has nothing to do with the proportion. Now 90%, that is the z-score. Z-score is going to equal to 1.6449. We calculated in the previous lecture videos. 6%, so they say we want the proportion to within 6%. So that tells that this is going to be the margin of error. Now we substitute these numbers into our equation. I have 0.25 for the p hat, so q hat is 0.75, 1.4669 divided by 6%, square them. So that gives you 114.194. So since, again, we need to be reasonable when we draw our conclusion, we want to know the sample size of how many people we want to survey. So it doesn't make sense we survey 0.94 adults, right? So that means I want to round this to 141. So that means we want to survey 141 people of this younger age group in order to estimate the proportion of non-graduate within 6% of 19% confidence of interval. B, suppose we want to cut the margin of error to 4% with the same confidence of interval. What's the necessary sample? Well, n is equals to p hat, q hat, z-score, margin of error square. So p hat still 25%, q hat 75%, z-score the same. Since it's 19% of interval, the z-score is 1.6449. Margin of error. Now they want it to be reduced the margin of error to 4%. All right, by calculate that, this is equal to 317.11. In this case, you may think about round down. Think about we wanted to reduce the margin of error. That means we need to at least to sample 317.11 of people. In that case, we have to round up. Even though this is less than 0.5, we still need to round up. We want it to be more accurate. Now, compared to these two problems, if you want a smaller margin of error, that means you need to sample more people, which we talked about that at the first chapter or first module or first week. We talked about the more people you survey, the more likely you will get a better accuracy. Okay, so that's it for today's class. Let me know if you have other questions.